Hello everyone, my name is Shashwat Singhal and I am pursuing BTech in Computer Science from Moradabad Institute of Technology. I am in my second year right now and today we'll be working on this data analytics project in which our aim is to find the top 10 most suitable villages where government can implement their Beti Padhao Beti Bachao Abhiyan. So for this, we'll be using Google Colab and using libraries such as Pandas and Matplotlib. But first, I would like to express my immense gratitude towards Team Explorin because in their placement guidance series program, I was able to learn this all in just 2 days thanks to the amazing mentorship and guidance of Abhishek sir and Utkarsh sir. First, we need to import the data to our notebook. For that, we'll do git clone and the git repository link. Now, as soon as we'll execute this command, our data will be imported here in our notebook. Now we'll import pandas library as pd. We have imported pandas. Now our next step will be, since we have imported the data, as we can see here is the data. So I'll copy the path of the data and now I'll store this data in a variable. We'll name the variable as village is equals to pd dot read csv. Read csv is a function in pandas library which is used to read csv file. CSV is basically comma separated values file. It is basically a text file, and then we'll paste the path, and as soon as we'll execute this line of code, our data will be stored in this variable village. Now what we can do is, first we'll check whenever we are beginning with data analytic project, first our task is to check whether our data is clean or not. So let's see what parameters we have in this data. So for that we'll do village.info. This will tell us about all the parameters that village have. For example, we have state code, state name, district code, district name, total population, male, female, and we also have like data about schools, government schools, private schools. Yeah, we also have data about area. So let's check for any data which can be a noisy data or like the error data. So for that, what we can do is village dot describe. A describe function is used to like, for example, I just run describe as it is. So it describes the data that is stored. So village.describe is describing about every data like state code, district code, total household. And if I do it like village dot describe, let's say I want to describe a particular value, like here when I did village.describe, it described every data. Like we can see there are total 631 state codes, right? And the mean of the state code is 17 point something. And if we see like total population, then we can see the max population is this, the minimum population is this, right? And the mean of the population and some other data as well. For example, here we can see government non-formal training center, the minimum is 0. Like some places don't have any training centers, right? So if I, let's say, want to just describe a particular data, then I can write it here. For example, let's check the area, right? So as soon as I'll execute this line of code, I can see that here is some error, like minimum area is 0, which is not possible. There can't be any village with 0 area, right? So what we'll do, we'll find out the villages which have 0 area and we'll drop that data, right? Because we don't want any error data on noisy data in our data set. So what we'll do to drop this error data is village area index. First we'll store the indexes of these villages which have 0 area. So village dot index function basically finds the index, and we will store the values or the indexes of village area hectare which have area equal 0. So what this line of code will do, this will line of code will store the index of the areas which have area less than equal to 0. Now what I'll do is I'll use .toList function so that the indexes will be stored in the form of list. So if I want to print, then I can just simply write print village area index, and I can also print the length by using length function, village area index. Now as soon as I execute this line of code, here are all the indexes with village area equal to 0, and there are 35 such places, right? So now I'll drop this data. So for that I'll use village. I'll create a new variable called new village which won't have any error data, and new village will be equals to village dot drop function is used to drop such data, and we'll drop the data present at the indexes which we have stored in village area index. As soon as we'll execute this, the new village won't have the area with 0 indexes. So how can we check that? We can check that by new village dot describe area hectare. Spacing the underscore. Just showing some error. Yeah. So this is the error. So as you can see, the minimum value is not 0 now, it is 1 point something, right? So we have removed the faulty or the noisy data from our data set. So now what we have to do is we have to find out the villages which are best suitable for our campaign. So what can be the most important parameter? It can be sex ratio, right? So we'll create a variable sex ratio which will be equal to new village dot total population female by total population male, right? So now this variable will have the sex ratio. This is defined for sex ratio. Now what we are defining sex ratio as total population female by total population male. We are so what type of villages we want? We want villages with less sex ratio, obviously where females are less, because we want to create more awareness there about this scheme Beti Bachao Beti Padhao, right? We will create this variable as village sex ratio so it is more understandable. Now let's say I want to plot a histogram of this data of sex ratio. So what I'll do is I'll import matplotlib dot pyplot as plt. After importing this library, I'll use the function hist and put this here, and when I'll execute this line of code, it will give me a histogram about sex ratio. So as we can see here, we have a lot of villages between 0.9 and 1, having sex ratio between 0.9 and 1. So I think we will consider the villages about less than 0.9. Now what I will do is I'll store the indexes of those villages which have sex ratio less than 0.9. All I do it, I'll create a variable which will store the indexes. I'll name this variable at village with less sex ratio index, and this will be equal to village sex ratio dot index of the villages where village sex ratio is less than 0.9, right? And I'll store this data in the form of list. After that, I can print let's say the length of this so that I'll know how many villages are there. And after executing, I can see there are 114 villages with the sex ratio less than 0.9. So now I want to further narrow down this data. So first I need to fetch the data present at these indexes, and then I'll narrow and then I'll work on that data set only. So what I'll do is village with less sex ratio is equals to new village dot loc and location of this. Now using this .loc function, what I have done is I have fetched the data, presented the indexes stored in village ratio index, and I have stored that data in village with less sex ratio. Now what I'll do is if I just write village with less sex ratio dot head, so as you can see, these are the villages, these are the districts like Kargil, Rajwari, Kathua having less sex ratio. Okay, so now we want to narrow down this data further. So what we can do is let's check what info we have. So what we'll do is village with less sex ratio dot info, right? Now we can see we have different data like total household population, and I can see here we have total population male scheduled caste, and total population scheduled tribe. So we can narrow down our data on the basis of sex ratio of scheduled caste and scheduled tribes. So let's do this. So what we'll do is village sex ratio SC ST is equals to village with less sex ratio dot total population female SC plus with less sex ratio total population ST. Now we'll divide this by male population divided by male and male, and when we execute this line of code, now we have the sex ratio of SC ST population. Now we will find villages with less sex ratio of SC ST. So what we'll do is, first let's plot the histogram of this so that we can visualize our data better. So as we can see here, about less than 0.9 or to be more precise, less than 0.86 something, we have only about like 15-16 villages, I guess. So we'll take the villages with sex ratio of SC ST less than 0.86. So villages with is equals to village sex ratio SC ST dot index of village sex ratio index of village sex ratio less than 0.86, and we will store this data in the form of list, and we'll print the length of the list so that we can identify how many villages are there. So as we can see, we have about 13 villages. So if we want to narrow down it further, what will be the parameters in which I can narrow it down? So for applying any parameter, first let's convert these indexes in the form of actual data. For that, first I will create this variable as index, because we have indexes stored in this, right? Now what I'll do is I'll fetch the data present at these indexes. So for that I'll use would be is equals to new village dot loc of these index, and when I'll execute this code, now I have the data of these indexes in my village with sex ratio SCST variable. So now if I do something like village dot info, so not village dot info, village with yeah dot info and execute this. So now I can narrow down my data on the on some other parameter. So let's take education parameter. So how can I check for education parameter? I'll do village with lex ratio SC/ST dot describe. Now what parameter I want to check, I'll just input in these square brackets. I'll, let's say, copy government primary schools. So let's see how the government primary schools are in these villages. So there are at least two primary schools in each village, right? Like minimum number of primary school is two, and mean is about 1019, about 1000 something is the mean of this primary school data, and there are even maximum of 2391 primary school. So what I can do is I can select some other parameter. Let's select some parameter in which we have like no, like the minimum value is 0. So let's try pre-primary schools. Oh, sorry. So I can see minimum pre-primary schools are 0 and the mean is about 50, right? So average they are 50 schools. So and 75% have 108, right? So I can narrow down my data on the basis of pre-primary schools also, or I can select some other parameter as well. Like I can select secondary schools, for example. Let's check secondary schools. So as we can see, we have a minimum secondary school 0, and about 75% of villages have 113 government secondary school. So if I want to narrow down my data on the basis of government secondary school, what I can do is target villages equals to dot index villages. This thing, let's see, government secondary school. Less than, let's say here we have 113, we take about 115. So if I execute this line of code and I store this data in the form of list, right, and print the length of my list, which is target villages. So I get about 10 villages, which is the exact number that I want. And now I want to know what are these villages. So simply I'll do target villages. Okay, let me just create this variable as target variable index. Target villages index, because what we have in here is just index, right? Now target villages is equals to let's say new village dot loc and location of what no, location of target villages index. I want the data present at the target villages index. right? On executing this, now if I do target villages dot head 10, and if I execute this, these are the villages where which I am going to suggest to the government for implementing these schemes. As we can see here, most of the districts are from Uttar Pradesh, like Hardoi, Kannauj, Etawah, uh, Hamirpur, etc. And one is from NCT of Delhi, and one is from Chandigarh, and another one is from Madhya Pradesh. So this is how we narrowed down our data. First, we narrowed it down on the basis of sex ratio, then we narrowed down on the basis of sex ratio of SC/ST, then we narrowed it down on the basis of availability or number of government secondary schools. So we have completed our mini project. Thank you.